Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2013 from topic method of variation of parameters. Here in the question, solve the differential equation by the method of variation of parameters. Differential equation is given by d2y upon dx2 plus of a square y is equal to sec a. Let's solve the problem. Given differential equation is, this is given by d2y upon dx2 plus of a square y is equal to sec ax. We have to write auxiliary equation of the differential equation. Auxiliary equation of given differential equation is, this is given by m square plus of a square is equal to 0, and from here m square is equal to minus of a square, and we know that in the complex quantity, that is I square is denoted by minus of 1. So we have to write here, this is m square is equal to, in place of minus we have to write I square into a square, and we get the value of m is equal to plus minus of I. Here are the roots of m are given by m is equal to ai and m is equal to minus of ai. First we have to write the complementary function of the given differential equation. Complementary function of the given differential equation is, this is given by complementary function, this is c1 cos ax plus of c2 sin ax. Here the roots of the m are in complex quantity, so we have to write complementary function, and further we have to find the given differential equation of that general solution with the help of method of variation of parameters. Let particular integral is yp is equal to v1 y1 plus of v2 y2. Here y1 is cos ax and y2 is sin ax, and v1 is given by integral of y2 into r upon w dx, and v2 is given by integral of y1 into r upon w. Here w is Lagrangian and r is comparing with the differential equation. Here from r is sec ax. So we have to put here, and we can also find here from y1 dash, this gives differentiation of cos ax with respect to x, this gives minus of sin ax, and ax differentiating with respect to x, this gives a, we have to write here minus of a sin ax, and y2 dash differentiating with respect to x, this gives cos ax, and again ax differentiating with respect to x, this gives a, and further we have to find the Lagrangian, that is w is given by y1 y2 and y1 dash and y2 dash. We have to put in the determinant. The value of y1 is cos ax and y2 is sin ax, and y1 dash is minus of a sin ax, and y2 is a cos ax. And further we have to solve the determinant. We get the value of w on cross multiplication with this gives a into a cos a square x square. We have to write here, this is cos of ax ka whole square, plus when we have to multiply this side of cross multiplication, here is minus is already present, and we have to, when we have to multiplied with cross multiplication, taking minus. That's why minus minus is plus. So we have to write here. This is a sine ax का whole square. Sine square ax. We can also write here. This is once again. This is not a angle square. This is cos square ax, and this is sine square ax. And we have to once again we have to take common a from here. This gives cos square ax plus of sine square ax, and we know that cos square x plus sine square x is 1. So we have to write here the value of w is a, and we have to put it here. Put here we have to find first v1. V1 is given by minus of integral y2. Y2 is here sine ax, and r is sec ax upon w is a, and this is dx. And we have to write here, this is sec ax is taken to denominator. This gives minus of 1 upon a, and this is sine ax upon cos ax, and this is dx. When we have to solve the given integral, let cos, once again we have to multiply numerator and denominator with a. This is v1 is equal to minus of 1 upon a square. When we have to multiply in the denominator, this gives, and in numerator this gives a sine ax upon cos ax, and let here this is cos ax is equal to t. This gives minus of sine ax, and again ax differentiating with respect to x. This gives minus of a sine ax, dx is equal to dt, and from here dx is given by dt upon minus of a sine ax, and we have to put here, we get the value of v1. This is v1 is equal to minus of 1 upon a square. Integral is a sine ax upon, we have to let cos ax is t, so we have to write here t, and in place of dx we have to put dx is dt upon minus of a sine ax, and from here a sine ax is ax and x to cancel out, and the remaining is here v1 is equal to, here minus minus is also plus, this gives 1 upon a square and dt upon t. This gives log of t, so we have to write here 1 upon a square log of t, and earlier we have to let cos ax is equal to t, so we have to put here, this is 1 upon a square log of cos ax. Further we have to find v2, and v2 is given by integral of y1. Here y1 is cos ax, and r is sec ax into sec ax upon, here w is a into dx. When we have to sec ax is taken to denominator, this gives integral of 1 upon a cos ax upon cos of ax dx. Cos ax to cos ax is cancelled out. We get v2 is equal to, on integration of dx, this gives x, and 1 upon a is already put in, this is x upon a. Further we have to write the particular solution here. This gives yp is equal to, v1 is, we have to calculate, v1 is 1 upon of a square log of cos ax into y1. y1 we have to calculate once again. y1 is cos ax. Once again we have to rough. y1 is once again here when we have to find y2. This is y1 is cos ax. This is cos ax. y1 is and plus of v2. v2 is here x upon a and y2 is here sin ax. We have to write sin ax and we have to write a complete solution. This is given by complete solution is given by and general solution. We can also write general solution. This is given by complementary solution plus particular integral. This gives complementary solution is this is complementary solution. This is c1 cos ax plus of c2 sin ax plus we have to write here particular solution. This gives 1 upon of a square log of cos ax into cos of ax and plus of x by a into sin ax. This is the required solution of the given problem. UPSC asked in 2013 for 10 marks. When we have to solve with the help of method of variation of parameters, we must remember the formula v1 and v2. First we have to find complementary function, then we have to find particular integral and we have to add complementary solution plus particular integrals. We get general solution or complete solution. Thank you class and thank you for watching.